So yeah, hi everyone, welcome back to our daily LeetCode challenge series. So today is day 65 and today we are going to solve LeetCode problem 41, first missing positives. Okay, so this is a hard level problem in the LeetCode. So let's see the problem statement first, then we'll deep dive into the solution part. So yeah, we have given an unsorted integer array nums. Return the smallest positive integer that is not present in nums. Fine. You must implement an algorithm that runs in big of n time and use big of an auxiliary space. Fine. Okay. So let's see the example for better understanding. So we have given one input array nums 1 to 0. So here the range is like basically 1 2 and 3, and the minimum missing range in this one is like 1 2 is already present, so 3 is missing, that's why we are returning 3, right? And in expansion we are given the numbers in the range 1 2 are already in place, so 3 is the minimum number that is missing. So based on the question, return the smallest positive number that is not present in nums. Fine. So mostly smallest positive is from 1 to the size of the array, right? In example 2 we can see we have 3 4 minus 1 and 1, so basically the size of num is 4, right? So 1 is present, 2 is not present, 3 is present, 4 is present. So minimum missing number in the given array is 2, that's why we are returning true. Same it is given in expansion, right? Example 3 we have given 7 8 9 11 12. So here the size of the array is 5, right? And the minimum number, as I already told, it should start from 1, right? So 1 itself is missing. We don't care about the number that is present, right? We have to find the minimum one. So minimum basically starts from 1 and we have to check whether from 1 till n is present or not. Whichever is missing first, I will return that one. So here in this case like all number is greater than the minimum range, so 1, as we are returning the smallest positive number, right? Fine. So in the given constraints we are given nums.length, and it can be ranged from 1 to 10 to the power 5, that is in the integer range, and value of num of I can be ranged from 10 minus 2 10 to the power 31 and similar, so it is also in the integer range. So fine, so that's all about the questions part. So now comes to the approach scenario. So one approach currently coming in my mind is we can first whatever array is given we'll sort it, and then we'll iterate based on index and compare if the index value is equals to the num of index value. If it is getting match, that means it is in place. If it is not getting match, that means that is missing. But only problem here is sorting will take like more space time consider, right? But as per the problem statement we have to do it in the within the big of n, so mostly we can iterate once, right? So second approach we can apply this we can do swap scenarios here, right? If we check that index is not getting matched with the required index, we can swap with the correct place. Let's suppose in example 2, yeah, let's say in example 2 we are checking this index and the value. If it is not getting matched, what we'll do, we'll just swap it to the original index. So 3 is expected to be in the 3 index, so basically in 0 index it is 2, so we'll swap to that 2 and minus 1 will come in the first place, right? This we will do till it will become sorted, right? So it can be done with O of n, but the thing is we have to do the sorting for applying this logic for each of the element given in the array, right, in order to make it sort. So it will ideally take the big O of n space time complexity and auxiliary space it is taking, because we are not going to use any extra spaces and all. So that is the second approach we can do, and mostly that approach I am talking about the swapping part is none other than the cyclic sorting only. So that's cycling sorting. Third one we can do, we'll keep a track of the each element, uh, and if it is already in place, then we'll make it assign some sign, like make it negative or something for tracking purpose. If it is already in that place, then it is fine. If it is not in that place, we'll make it as positive only, will not assign negative or any sign to that. So yeah, I think better, that will be better. We'll remove that swiping logic for now. We'll go through the simple logic, we'll do the indexing part of the correct one, and then we'll find. So that will be easier, right? And that will also can be done in a big of and like one time computing, space computing. So first, what we will do, in the given method we have nums, right? So basically I'm going to modify the given num itself, not going to use the extra space. So in order to do that, what I'll do, my first approach will be, first find the number that doesn't should be there in the given array. So let's say first we'll store the size, say size, and size will be nums dot length. Okay, now I'll iterate over each value. Okay, so for iterating I'll just go and not starting from 0th index, I should be less than n and plus plus. Now what I'll do, I'll check the correctness of the data. Correctness of data means like the value that is present at that index, it is expected to be in that range or not. So one is in example one, it is in the range. So for getting into the range, we'll do one thing, we'll see nums of I should be greater than 0, right? That is an expected scenario. Or sorry, we'll take like we need to satisfy both condition, and num of I should be less than or equal to our size. So it should not go beyond size length. So in our case, if size is 3, so number can be 1, 2 or 3. It can't go beyond 3, or it can't be negative, right? So let's suppose in that case it is fine. But if it is not so, so we'll check that condition only. If it is not so, we'll mark that number itself. Let's say I is not in that range, so we will just make it as we'll assign let's say size plus 1. So for our tracking purpose, I am giving that index, let's suppose it is assigning to 4. So let's say it is given 5, I'm assigning 4 because there is no use of that, and it should be size here itself because I'm taking size, right? So this way I'm just removing the irrelevant number present in the array with size plus 1 value, right? So first step I have done. Second step, this is the core part, mostly of this problem. Now again I'll start index from 0, it should go till size and will increment by 1. Now what I'll do, I'll check if current terms of I is in the range, or we can say it should be less than or equal to our size, means it should be under 3. That means that is an expected value, right? So in that case what I'll do, and here also one thing keep in mind, that as we are making it that value modifying which is not expected. So in example 3 case, here we see if 7, 8, 9, 10, 11, so all will be converted to the 6, right? Because the array size is 5, it will convert it to 6. Fine. So now it's time to check the current value. So we'll take cur, and there can be possibility it is in negative value or something, right? So I'll tell you what I'm doing here. We'll take the absolute value of the current nums of I, okay, and we're going to check current is less than or equal to size, right? If it is so that is expected value. Now what we'll do, we'll just assign that value. So our current -1. So basically array is in stored in the 0th index, right? Like a 0th index based. So based on that only I'm doing math.abs. So whatever absolute value of this one, current one, I'll make it as negative. I'll tell why I did this. Okay, I'm making it is negative because on the next iteration what I'll do, I'll check if this position element is in negative, that means that is expected one, right? But if it is in positive, remains it is in positive, that means that is not in the correct position and that number is missing. So let's say an example 2. Okay, so 3, it will assign 3 minus 2, so it will go to second index, which is the expected index of this one. So it will mark it as whatever value is 3, it is 3, it will mark it as -1. So that value is present, that we have tracked. Similar way in second iteration it will come, it will check 4. Okay, so that's why I'm given here. So let's suppose in next iteration it must become from a starting index from 0, 1, 2, right? As we have already assigning is -5, so we'll check if their absolute value. So ideally it should not be -1 because of this, right? So that's why I'm doing absolute value of that one. So it will make the positive and check if it is expected value in this node, then fine. Otherwise we'll don't touch that at all, right? So this is just for tracking purpose, like that element is expected and it is present for that index. Now in third iteration what I'll do, I'll simply run again same index starting for size and go to this one. I will see if nums of I is greater than 0, that means any positive value. If it is there, we'll simply return here because we have to return the integer, right? We'll simply return that value, not that value, because it can consist a different number. We have to return that index value. So ideally that index value is not present at all, so we are returning -1. Else we'll return size itself, right? Because if all number is already present, then we have to return the size array, right? So let's submit and see the test cases. So yeah, as you can see, like all 3 test cases got passed. Now submit and see other test cases as well. Okay, so looks like some issue, 167 only accepted out of 179. Fine. So let's see what is the problem here. So like assignment of the irrelevant value is fine if it is greater than 0 and still then fine, this is correct. Absolute we are finding and checking if it is lesser than the size, then we are assigning negative, fine. Okay, so the fault is here, as that is expected value we are giving, right? So it should be +1, because let's say 3 we can't return because that is expected value here, right? So it should be always return greater one. Now let's submit and see. It was my bad, like I missed +1 here. So yeah, like we can see like 179 test cases got passed, and it is 100%. That's quite good. And like as per the expectation, as we have three loops which is iterating till size of n, like size of the nums, and even 3n equals to n only, so it is big of n, a time complexity is big of n, and we are not using any extra spaces, just one constant spaces, so it is big of 1. So yeah, this is the solution. If you know any other approach like optimal than this, you can just comment it down. So that's all for today. Let's see you next video.